Today we're going to talk about the multiplication properties of exponents. Let's first set some ground rules. You have simplified exponential expressions if these conditions are met. There are no negative exponents, so we never want to leave a negative exponent. The same base does not appear more than once in a product or a quotient, so that means that you don't have something left that you can do, some multiplication or division that you can do. There are no powers raised to other powers. Again, that's a step that you can go ahead and take care of. No products are raised to power, so I don't have like 2x in parentheses raised to a power. No quotients are raised to power, so I don't have x divided by 3 in parentheses raised to a power. And there are no numerical coefficients that do not have a common factor other than 1, which basically means that there's no numbers that are not reduced. Now, here's some examples of expressions that are simplified, and here's some examples of expressions that are not simplified. You'll notice this one has a negative exponent. This one you have two bases that are the same that you're multiplying. You need to go ahead and put those together. Here you have a power taken to a power, so you need to take care of that. Here you have a product taken to a power, so the 4 has to go to the A and to the B. Here you have a quotient taken to a power, so the exponent goes to the numerator and the denominator. And here you have numbers that can be reduced. The 10 over 4 can be reduced to 5 over 2. So those are some examples. Here are our rules. The first one is called the product of powers property. So product means multiplication, and basically it's saying, what do we do when we multiply powers together? Here's the rule with variables. A to the m power times a to the n power is a to the m plus n power. Now, let's try this with some numbers. Okay, 3 to the second power times 3 to the fourth power is, now this means that there's 2 3's here. This means that there's 4 3's here. So altogether, I have 3 to the 1, 2, 3, 4, 5, 6 power. Do you see how we added the exponents together? Okay? If I have x to the 8th power times x to the 3rd power, that's going to give me x to the 11th power. Now, this works for everything. So let's say, for instance, I have p to the 6th power times p to the negative 8th power. I'm still going to add these exponents together. So 6 plus negative 8 is p to the negative 2 power, but that's not simplified because I have a negative exponent, so I'm going to write that as 1 over p to the second power. I put a little reminder over here for you that says, remember, a number or variable written without an exponent actually has an exponent of 1. I'll give you an example of that. If I have 5 to the 8th power times 5, that is going to give me 5 to the 9th power because there's that little understood 1 up there. Okay, and again, that is called the product of powers property. Our next one is called power of a power property. So I have two exponents or multiple exponents applied to one base. This rule tells me that in this case, I multiply them. I like to say multiple exponents applied to one base, you multiply the exponents. All right, let me give you an example. 3 to the second power taken to the third power. If I write this out, this is 3 to the second power times 3 to the second power times 3 to the second power. And then using the property that we just studied, we know we add those together. 2 plus 2 plus 2 is 3 to the 6th power. The shortcut is to multiply those together. Okay? So let's say that I have x to the 4th power taken to the 8th power. That's going to give me x to the 32nd power. Let's say that I have p to the 4th power taken to the negative third power. Now again, just because there's a negative there doesn't mean it changes anything. That's going to give you p to the negative 12th, which is not simplified. It will give you 1 over p to the 12th. So as we learn these rules, we have to keep building. We have to use the ones that we already know and then add to our repertoire. Okay? All right, the next one is the powers of product property. So basically this is applying an exponent to a multiplication problem. And it tells me that we take that exponent on the outside and give it to each one of the factors. Okay, each of the pieces that are multiplied together. So let's say that I give you 4x in parentheses squared. That's going to give me 4 squared times x squared, okay, which is going to give me 16x squared. If I approach this a different way and rewrote it as 4x times 4x, you would see 4 times 4 is 16 and x times x is x squared. Same thing. All right. This is actually the property that helps us with the difference between negative 2 squared and parentheses negative 2 squared. When it's in this parentheses, it's like having negative 1 times 2 squared, and that square goes to the negative 1 and to the 2. Okay? So let's try some of these. You should pause the video at this time, do these 6 problems, and then go back and check them. Okay? All right, so here we go. This is going to give me v to the 10th times v to the 4th, which is v to the 14th. Here, this square goes to the negative, that makes it positive. It goes to the 5, which makes it 25, and it goes to the k, which makes it k squared. Be careful here. You can only put together ones that have the same base. So c to the 5th times c to the 3rd is c to the 8th. And then that b to the negative 2 stays there, but that's not simplified. This has a negative exponent, so we need to move it down. So this is going to become c to the 8th over b squared. All right, tried to trick you on this next one. That negative is on the outside. That 3 has absolutely nothing to do with that negative. So 4 to the 3rd power is 64, m cubed, and then the negative comes and attaches itself on the front. All right, here, w to the 6th power taken to the 0 power. 6 times 0 is 0, so that's w to the 0 power, which we know anything to the 0 power is 1. All right, and then here we go. This exponent right here goes here and here. So x cubed taken to the negative 4th power is x to the negative 12th. Y squared taken to the negative 4th power is y to the negative 8th. Over here, this one goes here and here. X squared taken to the negative 2 power is x to the negative 4. And y to the negative 3rd taken to the negative 2 power. Negative 3 times negative 2 is positive 6. All right, now let's put these together. X to the negative 12th times x to the negative 4th is x to the negative 16th. Y to the negative 8th times y to the 6th, add those exponents, is y to the negative 2. This is not okay because these have negative exponents, so they're both going to move down. That's x to the 16th, y to the 2nd, and when everything moved off the top, what do I have left up there? Just a 1. Okay? You should be able to fill these out with the rules, and that is it.